Section 3.2 is simplifying expressions involving powers and negative exponents. This is review from Algebra 1, so we're just going to really quickly go over the rules of exponents again. When we are multiplying powers, so we have two bases that are the same, but the exponents are different. We keep the base, and then we add the exponents. Very similar to dividing powers, the two bases are the same, but the exponents are not necessarily the same. So we keep the base, and then we subtract the smaller exponent from the larger. So our answer would end up being the same base, and the exponent would be m minus n. So we just subtract the exponents there. If we have a power that is raised to an exponent, so in parentheses, and then the exponent on the outside of the parentheses, we multiply the two exponents together, and that creates our new exponent. But if we have something similar to this, where two numbers are already being multiplied inside the exponent, what we do is very similar to distributive property. We take that exponent and we distribute it to each term inside the parentheses. So now, in this case, each different base is being multiplied by the exponent, or raised to the exponent. The same thing happens when we have a fraction. We just take that exponent and we distribute it to each thing inside the parentheses. So our new fraction would become each different base raised to the exponent. Now, when we have a negative exponent, that's not allowed, so what we do is we take the reciprocal. So if we have something like a to the negative m, we just flip it upside down and we put 1 over a to the m, and then that exponent becomes positive. The same thing, if the negative exponent is in the denominator, we just move it up to the top and it becomes a to the positive m. So after we take the reciprocal, we can change that exponent to positive. And then we always have the zero rule. Anytime an exponent is raised, or a base is raised to the zero power, it's always 1 no matter what. So let's start looking at some of the examples. We want to, whenever we are simplifying exponents, we want to simplify and we want no negatives in the answer. So we have to make sure that all exponents are positive. So in example 1, I have 2ab squared times negative 4, a to the third, b to the third, c. So what we do in this case is we're multiplying different powers or different exponents, and we take each term that is the same. So we can only multiply and combine exponents of terms that are the same. So 2 and negative 4 are considered like terms because they're constants, so we can multiply those two together. 2 times negative 4 gives me negative 8. Then I have my a's. I have an a, which if there's an a by itself, it has an exponent of 1, and a to the third. So the bases are the same here, so I keep the base. And when I am multiplying different powers, I add the exponents. So 1 plus 3 is my exponent there. I go on to the b's and I do the exact same thing. I have b to the second power here times b to the third power there. So I keep my base and I add the exponents, 2 plus 3. And then I have c, which is all by itself out here on the right, so I just leave c like that. And then I can simplify each of my powers. So I have negative 8, a to the 1 plus 3 gives me a to the 4th, b to the 2 plus 3 gives me b to the 5th, and then I just have c to the 1. So this would be my answer simplified. None of the exponents are negative, so we can leave our answer as it is. Example number 2. we have x to the 11th power divided by x to the 5th. My bases are the same. They're both x, so I can leave the base. So I have x, and when I am dividing powers, I subtract the exponent. So my exponent is going to be 11 minus 5. So when I simplify that, I would get x to the 6th. And x to the 6th is a positive exponent, so I can leave it, and that is my solution. Example number 3. Is y to the 20th power over y to the 30th power. I'm going to do the exact same thing that I did in example number 2. So I keep my base because they're both the same. So I have y, and I always subtract the bottom from the top. So y to the 20 minus 30. Now this time, 20 minus 30 gives me negative 10, and I have a negative exponent. So what I do is I take the reciprocal of that. So we have 1 over y, and since I've taken the reciprocal, the exponent becomes positive. So my answer is 1 over y to the 10th. Everything is now positive, so that is my final solution. Example number 4. I have 1 over 3, all of that to the negative 5th. Times 2 over 3, all of that to the positive 4th. Now when I have something like this, the first thing I'm going to do is take care of all of my multiplication, and then I'll worry about the negative exponents at the very end. So I'm going to distribute both of those exponents to each of their fractions, which is going to give me 1 to the negative 5 over 3 to the negative 5 times 2 to the 4th over 3 to the 4th. Now in my numerators, we can multiply straight across because it's just a fraction, but in my numerator I have a base 1 and a base 2 here. So I can't combine those exponents at all. So right now I'm just going to leave it as 1 to the negative 5th times 2 to the 4th. All over. Now my denominator is a little bit different because my bases are the same. They're both 3. So I get to keep that base, and since I'm multiplying the powers, I add the exponent. So I have 3 to the negative 5th times 3 to the 4th, which gives me 3 to the negative 5 plus 4. So 1 to the negative 5th times 2 to the 4th. All over 3, negative 5 plus 4 gives me negative 1. Okay, now that I'm pretty much simplified as much as I can go so far, I'm going to worry about my negative exponents. This 3 to the negative 1 has a negative exponent, so to take the reciprocal, we're going to have to move that one up to the top. And this 1 to the negative 5 is going to have to move to the bottom to make those exponents positive. So what I'm going to do is I'm going to rewrite all of that, but this time moving those exponents. So on top, now I have 2 to the 4th times 3 to the positive 1, all over, and because I moved that 1 to the negative 5th down to the bottom, now it becomes 1 to the positive 5th. Now I don't need to stop here because these bases are numbers, so we actually can evaluate these. So 2 to the 4th power, that's 2 times 2 times 2 times 2.